You've run your test and gotten a number. The p-value turns that number into evidence. It answers one precise question, and it's the most misunderstood quantity in statistics. Assume the null hypothesis is true. Now ask, how surprising is the data you actually saw? The p-value is the probability, under the null, of a result at least as extreme as the one you observed. A small p-value means your data would be rare if the null were true. Evidence against it. On the null distribution, your test statistic lands somewhere. The p-value is the tail area beyond it. Everything at least that extreme. A tiny tail means you're far out in the wings, where the null rarely goes. To decide, compare the p-value to your significance level, alpha. If p is below alpha, you reject the null. If not, you fail to reject. Setting alpha at 5% is exactly the same as drawing the rejection region from before. Now the warnings, because these trip up nearly everyone. The p-value is not the probability the null is true, and not the chance that you're wrong. And significance is not importance. A tiny meaningless effect can be highly significant with enough data. The p-value is how surprising the data are, assuming the null is true. Compare it to alpha to decide, but never confuse a small p with a large or a certain effect. Next, the theory of the single best test, Neyman-Pearson.